Welcome to session 7, part A. I'm going to finish up one final topic of chapter 4 in part A, and then in parts B, C, and so on, I'm going to go to chapter 5. The part I'm going to clear up, the final aspect of chapter 4 that I want to go over is just the notion of the elasticity of supply. Now, this should be pretty easy. It's basically just the same thing as elasticity of demand, except instead we look at the supply curve. Okay, and the key is, I'll state the formula, is elasticity, call it E sub S, elasticity of supply. Actually, I don't even need to put the sub S, but we'll know it's elasticity of supply equals percent change in quantity supplied divided by percent change in price. Okay. So when we talked about one thing, when we talked about the elasticity of demand, we said it was always negative, and that's because when price goes up, demand decreases. It's going to be the opposite with elasticity of supply. So if the price goes up, percent change of price goes up, almost always, or generally what we will assume for this class, the percent change in quantity supplied, that the suppliers are going to want to supply more, so it will go up. So that means that both of these numbers are going to be positive, so positive divided by positive number is going to be positive. So first, that elasticity, we know it's going to be positive, okay, unlike the elasticity of demand. Now, let's give an example. Okay, let's start on page 89 of the 13th edition. Pretty sure if you're in the 12th edition, there will also be a similar paragraph. The key is the supply curve of military volunteers, in figure 4.3, blah, blah, blah. Okay, you see that. Okay, so okay, now we're going to do, but first it talks about the when the price changes between 7 and 9. Okay, now first it says that they are looking in figure 4.3. So let me show you that. Hopefully everyone has the textbook, but if not, this is it. Okay, if you have to, pause your video to get that graph. Okay, so let's talk about for that graph. So first, price changes from 7 to 9. Okay. Okay. First of all, when that happens, when price changes from 7 to 9, that means price increases by $2 from a base of $7. Okay, what's the increase in price? Well, it's 2 divided by 7. I have my calculator, and I get 28.6%. Okay, so that equals 28.6%. Okay, what happens to price change? What happens to quantity change? Okay, so when I look on the graph, so I look at when it's the price is 7, the quantity is 0.8, 0.82, and then when the price is 9, the quantity becomes 1.2. Note, no, I looked at those wrong. There are 4 tick marks, so each of those little white lines represents a quarter of a point. So actually, that's wrong. When the price is 7, the quantity is 0.75. 0.75, and then it increases when the price is 9 to 1.25. Okay, the percent quantity change, so that means that the quantity change is 0.5, 1.25 minus 0.75. The percent quantity change is 0.5 divided by the base number, 0.75, and that equals 66.7%. Okay, so when we compute elasticity, so that means E sub S should just equal percent change in quantity, supplied 66.7%, divided by percent change in price, 28.6%, and I get 7 divided by 28.6, I get 2.332. Okay, now, I want you to notice one thing. Okay, 2.332. The book says the price of elasticity varies along the curve, decreasing from 2.0 between 7 and 9. The book says it should be 2.0. Okay, why did we get that number? Okay, let me show you why. Okay, by the way, I don't want you to get too hung up on this notion. It says that it says we use the midpoint to compute the percentage. Okay, I'll explain that in just a second. If you'd put this on an exam, if I asked you to compute the price, the supply elasticity, and you put 2.332, that'd be correct. I'd say that's close enough. Okay, but let me explain why the book gets at 2.0. Okay, before I do that, let me do something slightly different. Okay, so I'm going to write down before that we got 2.332. Okay, and that's when we looked at the price change from 7 to 9. Okay, it shouldn't be that different. What if we looked at the price change from 9 to 7? Okay, the quantity change is going to be the same. Shouldn't the elasticity be the same? In a sense, you'd think it would be. Let me show you why it's not quite that. Okay, so now let's do from 9 to 7. Okay, the price change is 2. We changed $2. It's actually a decrease. If you like, call it -2. And that, but now our base is 9. Before we started, our base price was 7. We started from 7. Okay, now our base price is 9. So I'm going to use that. Okay, so -2 divided by 9, and that equals, I get 22.2%. Quantity change, it goes from, before it went from 0.75 to 1.25. Now it's 1.25 to 0.75. Quantity change was 0.5, but we had a base of 1.25. So the percent change is 0.5 divided by 1.25. And that, actually I can do this one in my head. That one is going to equal 0.4 equals 40%. Okay, so now the elasticity just equals change in quantities, change in quantities supplied, 40% divided by 22.2%, and we get 1.801. Okay, so notice we got two different numbers. Before, if we use our base, we go from 7 to 9. our price, our supply elasticity is 2.33. If we go from 9 to 7, our elasticity is 1.801. Okay. That is one of the problems with elasticity. Usually we say, well, if we're only looking at small price changes, if you trust me, if we'd change from say 7.999 to 8.0001, both of these methods would have gotten almost exactly the same elasticity. The problem is when we have a fairly big price change, so this one, okay, approximately something like 22 or 25%, all of a sudden the elasticity can change depending on what you use as your base number. Okay, that's the key thing. But by the way, if you'd done this method, if this would have been on the exam, and he said the supply elasticity is 1.801. Oh, by the way, let me explain something. So I said the price change decrease, so I have a negative number there. What about the quantity change? Actually, there's a decrease in quantity, so I should have had a negative number there. So I should have had two negative numbers, and we should remember from high school algebra 1, if we have two negative numbers, the negative ones cancel out, and we get 1.801. Okay, back to the main point, though. The key was, though, we changed what the base was. Before, we started as the base was when the price was at 7, and their quantity base was the quantity when the price was at 7, and then I changed. Now let's say the base is $9. The quantity base is the quantity at $9. Okay, that's when we get these two different numbers. And by the way, if you'd put 1.801 on the exam, that would have been correct too. Either one of those numbers would have been correct. Now, how does the book get 2? Let me explain what it does. The key is this base. Last time I used $7 as the base. This time I used $9 as the base. The book says, what if instead use as a base in calculating percentage changes the average of the two prices? Okay, sometimes we call it, in other books, they call it the midpoint method. So instead of using 7 or 9 as the base, let's use the middle of those two numbers, the average, and that is 8. Okay, so if we do that, let me use green as the marker for that case. We would just say instead that the price change is still the same. It's $2, but the base is different. We're going to use 8. Okay. The quantity change is still the same. It's negative 0.5. But the base, I'm going to use the average of those two numbers, 1.25 and 0.75. And that is 1.00. Okay. We get different numbers. And what we're going to get instead, the supply is going to be negative 2 divided by 8. That's negative 25%. This number is negative 0.5 divided by 1, and that is negative. Oh, excuse me. Okay, always, okay, I did one thing. I told you, remember, whatever you do when computing elasticity, remember the quantity goes in the numerator, okay? Price goes in the denominator, and that is what I forgot. It's an easy thing to do. Like I said, once again, I said if you're going to cheat and write something on your hand, now don't do that. But if you were to do that, the first thing is do a graph, P on the vertical axis, Q on the horizontal axis. The second thing I would write is elasticities have quantity in the numerator, not price, okay? So if we have quantity in the numerator, it's going to be negative 50%. 0.5 divided by 1.0 is 50%. Negative 2 divided by 8 is negative 25%, and that equals 2.00. Okay, so that's how they get that number in the book. It says the price elasticity varies along the curve, decreasing steadily from 2.0 between $7 and $9. Okay, And then it says it goes down to 1.2 if you look from prices of 23 and 25. Okay, I'm not going to do that. Okay, but that's a good exercise. Verify for yourself. Do the same exact exercises, or instead of prices of 7 and 9, try 23 and 25. When you want to know what's the base number divided by, use the average of 23 and 25. That's going to be 24. Remember also to use the average of the quantities, okay, the two different quantities of those two different prices as your base number, and you should get 1.2. Okay. Okay, so that was an example of price elasticity. Okay, next. Okay, 21. I want to look at the end of chapter questions, and we'll look at number 21. Okay, so 21. Okay, now I talked about it last time. I did A and B of for 21. Now I'm going to do C and D. Okay, 21. The supply curve is in figure 4.4, shows the weight that a person would have to be offered by business firms to obtain various quantities of hours of envelope stuffing on any given day. Okay, C, what will be the total opportunity cost to the envelope stuffers of stuffing envelopes? Okay, all right. Here is the way you figure that. So I'm going to recreate the graph. We have $10, we have $5, and we have 0. And then we have 100, 200, 300, 400. By the way, so part A said, what wage rate will firms have to offer if they want to hire 400 hours? Okay, so if you look on the graph, to get to 400, the wage rate is going to have to be 7. Okay. So we're going to have a dot at 7 and 400, and there's another dot at 0 and 3. Okay, and then at 100, it's going to be 4, 200, it's going to be 5, 300, it's going to be 6. So this should be a straight line. Okay, and this is the supply curve. Okay, what will be the total opportunity cost to the envelope stuffers stuffing envelopes? This is a hint. Each square represents $20, 20 hours times $1. And so, okay, the key is, look at that first 20. Okay, this was at numbers 20. The key to think about this, here's the easiest way, okay, is we think of that instead of 400 total hours, what we have is 20 times 20 is 400. Let's suppose there's 20 different people, and each person is willing to contribute 20 hours. Okay, and the way this would work is the first person is willing to contribute 20 hours, but only if he or she gets a price of $3 an hour. Okay, second person would be this one. We want a little bit more than $3 an hour. I think the number would be something like $3.20 or $3.40. Okay, whatever the case, this first person is willing to stuff envelopes at $3 an hour. What is his or her opportunity cost? He says, well, okay, my alternative is do something else and get 60 total dollars. I get $3 times 20 hours, and answer is that area, that rectangle area. Okay. So that person says it's worth $60 to me. Okay. What about this person? This is the sixth person. Okay. Who's willing to contribute the 100th to 120th hour. This person needs to be paid $4. So this person's opportunity cost is 20 hours times the $4. So that person's opportunity cost is $80. Okay. So the answer is, what is the total opportunity cost? Well, it's just the area. We can keep on doing this and adding these rectangles. The total opportunity cost would be the sum of the area under those rectangles. And even though I made it a rectangle, actually this person, I think you call it quadrilateral, or I can't remember that, rhombus, trapezoid. Can't remember. It's one of those words from 9th or 10th grade geometry. It's not quite a rectangle, but it's something almost like a rectangle. And that the area, it's going to be approximately the same area as the first rectangle I drew. But the correct answer is it's going to be that area under that curve, under that supply curve. And the total amount of opportunity costs to get 400 hours is going to be just the area underneath the supply curve. Okay? So that's the answer. The area underneath the supply curve. This quantity goes from 0 to 400. Price goes from 3 to 7. The answer is, if you remember from back to 9th or 10th grade geometry, the area under that curve, well, the length is 400, and then the average height is the average of 3, because it's the line, average of 3 and 7. So times the average height is 5, and so the answer is going to be 2,000 total person hours. Okay, so that's the answer. The key is to get, if this were like a 4-point question on an exam, if you just said the area underneath the curve, you get 3 out of 4. To get maybe that last point, you need to be able to remember that formula from geometry. Now, the key is, though, the total opportunity cost was 2,000. Here's what question B asks. What will be the firm's total expenditure? Okay, here's what will happen. So the firm is going to pay a wage of $7. I'm getting ahead of myself. This is kind of foreshadowing some problems we'll look at in the next couple chapters. But if the firm pays $7, pays a total of 400 hours, the total expenditure equals 7 times 400 equals 2,800. Okay, so the answer is the firm, or the buyer, is going to pay 2,800. The opportunity cost of these suppliers, these people who are willing to stuff envelopes, is only 2,000. So in a sense, they're making a profit, and the profit will look like the area in between, in the area in this green triangle. Okay, this is beyond the scope of chapter 4, but I'm just giving you a little bit of foretaste of where we're going. Okay, the key is, though, I want you to see that the total expenditure was different than the total opportunity costs of those suppliers. Okay. What is the price elasticity of supply between $4 and $6? Okay. You also ask, what is it between 6 and 8? Okay. Let's do this. That's right. Elasticity of supply between $4 and $6. Okay, so goes 4 to 6. The change in price is $2, okay, divided by the base. You could put 4, okay. Alternative, you could have put 6 as the base, or you could put the midpoint, okay. To what? So if you do any one of those three, you'll be correct on the exam. Usually, lots of textbooks say use the midpoint. Doesn't matter. I'm going to do the easiest. I'm just going to use the first number, 4. So the price changes from 2 to 4. Okay, that's equals 50%. So ES equals percent change in price. The numerator is percent change in quantity. Quantity changes when it goes from 4 to 6. The quantity changes from 100 to 300. Quantity changes from 100 to 300. Okay, so I get the change is 200 divided by the base 100 equals 2.0 equals 200%. Okay, so the answer, elasticity of supply, is 200% divided by 50% equals 4.0. Okay, so that would be the answer on the exam. You'd get a slightly different answer if you used a different base. You could have used 5 for that number, or you could have used 6 for that number. Similarly, instead of that 100 as the base, you could have used 300 as the number, or you could have used 200 as the number. You'd get slightly different answers. Any one of those would be correct on the exam. Okay, so that was part A. That was of this lecture, Elasticity of Supply. Okay, see you in part B, where I will start chapter 5.